Hello and welcome back to Poor Man's Electronics Bench. Are you the kind of person that can't leave well enough alone? Always thinking that there's some little tweak, adjustment, or modification to something that may enhance its ability to serve you better? Well, you have come to the right place. I have found that I just didn't want to leave that added banana jack that the previous owner installed in my Eico 1140 unit because it was really no use to me at all. I was schematic viewing on this device and I saw an opportunity to make an improvement that might enhance its adjustability on the resistance substitution selections. I was wondering how hard it would be to connect the low and high range switches in series, and then a user could tweak a higher resistance selection by adding a lower one in series. This is my attempt at this modification by using only a single pole, double throw toggle switch and interrupting and switching the common bridge connection from each switch to a series connection. If you are interested in this information, please stay tuned. Hello and welcome back to Poor Man's Electronics Bench. I am going to do an addendum to my Eico 1140 rework. I just sat down and was thinking about that extra return jack that was added, or negative polarity, or whatever you want to call it. It's really not serving any purpose as far as I can figure out for the wiring. As far as functionality, you can't really split using the capacitors and the resistors at the same time the way it's wired. It's not really doing anything except filling up a hole in the front panel, and I was thinking, what can I do about it to make something else happen with this unit that might be a useful feature. One thing I was thinking about is the two switch decks for the resistances. One's a low range, the other one's a high. Neither one can be used in conjunction with each other. They're kind of separate. They're separated through this switch totally. I'll show you that on the schematic. And what I was wondering is, what if I can put these two switches in series? Thereby, let's say if I had a circuit that I wanted 100 kilo ohms for, but I wasn't quite sure what the exact value is. It might be associated with an oscillator or something along those lines, or something that was very current sensitive. Granted, this box won't have the adjustability of a 1 ohm discrete component decade, full-blown decade box, but with the subtraction of a jack that's not doing anything and the addition of a small switch, I can add a little more adjustability to that. I put this, keeping this in the 100 kilo ohms range, I can make adjustments in steps from an extra 15 ohms to an extra 10K in that resistance range, and it might make a difference as far as some troubleshooting or not. And if anything, it'll add, like I said, it'll add some adjustability and functionality to it, and it'll just kind of make me feel like I accomplished something if this actually works. So at this point, I'm going to go into tearing open the box. I'm going to add a switch, single pole double throw switch, interrupt the wiring on the wiring bus connection between the two commons and all the resistors, and switch the output of this to either go back through this switch or to go in series with the input of this switch, which would make these resistors go through into this switch, through these resistors, and then to the output. So I'm going to do a little schematic verification to make sure I can do that along the lines of things once I separate the two switch decks, and then go ahead with the modification. And I'm going to have some discussion on the schematic and how I figured I could possibly rework this to make this happen. I am going to take a page right out of the book of Manuel Caldera's experience. He has an electronics repair page called Electronics Old and New, and he has a lot of good ideas and a lot of talent to go along with things. And one of his strong points is really breaking down schematics and isolating portions of them while he works on them, and also highlighting signal paths through a device as far as getting through certain components in order to figure things out. And he's one of the best ones I've seen, and he does it in a way where it's not clumsy at all. I don't have a full-blown Adobe Reader editor to do that with, but I'm going to have to use the software paint.net and follow through on some stuff. And I'm going to go through what I visualized in my head as a connection path to join up the low and the high resistance switch decks in series with each other, so you can make some finer adjustments on a higher resistance by incorporating the low range in series with them as well. So what I'm going to do is, we've got our two jacks here, we've got our function switch, and this switch has a lobe that's going to connect, when it's rotated to the proper position, it's going to connect these two connections, and it'll also connect this one back into this jack here for resistors only. So I'm just going to go through and start highlighting that connection path. It's going to go through here, let's say the switch portions, working my way up to, this is the low high range switch. Now we're going to make this work by making sure that the low high switch is in the low position. That's the only way this is going to work properly. So we're going to go to the common on that one, to the low, and we are going up to the common of the rotary switch. In this case, I believe it's terminal, hard to tell, these are lettered or numbered, but anyways, it's going to have to go to the common. Now in this case, what happens is it goes through one resistor, and then on the common side of both of these resistor arrays, there is just that solid piece of copper wire, which I'll highlight later. And if we take that and interrupt it, not really interrupt it per se, but what I'm going to do is, normally that will just go down to the common here, to this switch post, and then out through the other binding post on the panel. And instead what we're going to do is interrupt this with another switch. Let's see, we'll make a switch contact here, and we'll complete this path as one of the switch positions, and then the other switch position will be here. So in the case of making the connection through here, what we would have to do is make a connection to this switched pole on this rotary switch assembly. If we came down, did that, it would go through, then our resistance would be open here, and it would be forced to go through whatever resistor that was selected through the high range by the switch contact. So that would allow us to make finer adjustments of the series resistance by using both switch decks, and that can be returned to a normal function just by taking the switch contact and moving it back to its original configuration. So in theory, that's a working model. The only thing we have to do is we have to use this contact off this rotary switch is a common, and this will be the two switched poles on a, or the two switched contacts on a single pole double throw switch. So that is what I am going to attempt to do to my Eico 1140. And I've decided to commence with the festivities of starting to open up the Eico 1140 and remove the jack here. I'm going to speed things up a little bit, but going forward for this part of the video, I hope that there's not too much background noise, because a local resident has acquired themselves a new to them high horsepower, low restriction exhaust V8 powered vehicle, and has decided to go speeding around the neighborhood just to test their prowess with their new acquisition, and it is annoying as all hell, but we'll see what happens here. And then also for this part of the video, I'll speed up the actual disassembly until I get to a point where I'm going to make some test connections to see if my supposition of adding this switch is going to work. So here we go. Okay, I removed the protruding banana jack and also the bridge between the two resistor arrays, and up till now everything I've done has easily been no harm, no foul, reversible. But what I'm going to do is go to my planned schematic connections of taking the low resistance bridge ring and hooking that to the switched terminal which should put my low and my high range resistances into series. So starting out with, I'm going to, and this switch has to be, I believe, in the low range to make that work. There's a little bit of a connection issue where I believe that if that switch is in the wrong range, the two switches are in the wrong range, it might be a short circuit on the output. I'm not going to worry about polarity on these, it's not an issue. So right now, okay, that is a short. This connects to a short as well. And right now something in my schematic scheme is not working, so I have to I might have my switch configurations in the wrong order. Output of the low to the common on the high. Let's try that. Okay, that is a short circuit with no connection as well. So I have to sit back and rethink what I'm doing here. Oh wait, I'm in continuity here. Continuity doesn't always give an accurate ohm reading. Resistors. Okay, that was my problem. It was operator error on the digital voltmeter. I was in a continuity mode. If you could see it, see, I go up to 100K to make this more obvious here because it's closer. It's 99.17 kilo ohms with a 15 ohm resistor. The switch is in low. If I start to go up range here, if you notice, my increments on my resistance are changing very slowly. I've added 100 ohms from the original. It was 99.17, so it's 99.26. If I go up to 1,000 ohms, so that is behaving just like I figured. And if I switch back to the high range, it isolates the low range values and just goes back to the high range when this is engaged. So that isn't a bad deal because it won't cause a short circuit in any way. I was calculating or routing that it might cause a short circuit, but this is actually working pretty acceptably here. So let's say I've got a 2200 21.76 value and you'd like to be able to tweak that a little bit. Well, there you go. I can add the 10K in that, so that's 31K. So that's, looks like it's working out just exactly as I drew up on the schematic modification. So I'm going to go ahead and wire that up, and I'll probably speed the camera view up along with that. And I do have to remember on my wiring that my switchable pole is going to be from my low range commons to the, it's either going to be going to the input or the output of the switch gang for the high range, or it's going to go from the low range commons directly to here. So that's what I'm going to have to add the switch in and add the proper wiring to obtain those connections. Okay, and if I did this right, I have the toggle switch installed. The throw of the switch is going to, the bottom position will connect the top two contacts. One contact is put to the center pole is put to the low resistance resistors, which is there. And then the bottom pole, which would be the top position of the switch, is connected to what would be the output of the selector for the high resistance switch, and then the other side is put back to the common ring on the high position switch. So if all went well, this would be the normal position up, and this would be the combined low and high position. So we're going to give it a whirl. Got my properly configured meter again hooked up. Still in the resistors switch on the selector. So that is the, if you notice, that's the normal position, and if I put this switch in position, it should go to 22K. 21.756K, because it's combining this switch selector and this switch selector's resistors. And then going up, I can add this resistor value onto the other one. And I should be able to go all the way up to about 32K with this. And it does. And then, like I said, switching this in the combined series position, taking this and switching it to high, it should just eliminate these switches and go. I'll prove that again by going back to 10K and adding that 10K resistance on there. It's 31.6. This should drop down to close to 22K again. And it does. So it's not going to create any problems going forward. I'm just going to lose my combination. And then also going back to this also does the same thing. It's kind of just like a redundant path between the two, but I go back to my low resistance selector switch of 10K value coming up as 10K in the meter. So I would have to call that a success. And the only other modification I made to this, I went through some trouble. It looks a little strange, but I did go through some trouble. I polished the bakelite, and it actually came out pretty good. I used some hand polish, but then what I did also was trying to protect things in the future. I put some clear packing tape on it just to provide some control from abrasions. And the bottom was in nice shape, but I put some rubber padding on that as well, because this is something that might get some use. And I might even come up with something to further protect this. I've got some insulating cardboard I might wrap around the outside and tape as well, because all of this can be reversed very easily without damage. But yet, I just want to keep this bakelite in good shape, because it is really in nice shape. It's a Decaware product from Chicago, Illinois. It's a homebrew product. The housing and the knobs are both made in the same area of Chicago. And I used, if you noticed, I used a pretty salmon pink wire. I've got a box of 22 gauge solid wires, and it's one of 8 colors, and it's probably the one color I'm not going to use much going forward in the future, so I wasn't worried with burning up some of that wire. And that would be about it for these modifications. I'm happy. The only thing we're going to do is add a little. I've got some Dymo label maker clear on black. I can add up a little label, and I think I'm going to do that. If you stay tuned, I'll pause the video and I'll show you what the results look like in a second. And with a lot of fumbling around, I managed to get the label maker stickers printed up, 2mm size, and some trimming. And this is something that in my employment world, I used to have to stencil what would be called DSX panels, digital cross-connect panels, for DS1 signaling from equipment to equipment point. I have to use a smaller font and cut up and make little custom labels to go on things, and looks like it came out okay to the point where it's legible and will function for what it needs to. And I'll probably add a little up and down arrow as well, just to give people the idea that no, the switch does not go from side to side, it goes top and bottom. So I'll add those on as I see fit, but I'm going to double check things one more time here. We are in the normal position, low resistance, 10K ohms. We're reading 9.9. If we go to The high range on the slide switch, we have 22K. Going back to the low and engaging the low and high in series, we are coming up to 31.6, and we can vary our range down from 10K. So everything seems to be functioning in a proper manner. And like I said, this is something that I can't see too many people wanting to do with their items, but like I said, I had the opportunity to make a change out of something that wasn't useful to something that's more functional for me. Seems to be the little added bonus item, and I hope that anybody that stumbles into this, at least they have some information on one modification that can be done to enhance its capabilities. These units I'm seeing still up for sale on eBay from anywhere from $40 to $60, and I'm really, unless somebody actually took very good pictures of the phenolic switch decks on these, because these switches are inherently a bit fragile. I've seen them get damaged a lot of times. This unit's lucky to have a good set of fully functioning, non-bent, non-cracked switches, which really makes a difference. If somebody gave some good interior photos and or gave the possibility of return after a buyer opens it up and examines it, because I know sellers don't want people to open things up and harvest parts out of a working system to fix their broken one. I totally sympathize with that, but also the buyer should have somewhat of a chance to examine things well before they make a purchase. And even if a seller was willing to give some sort of close inspection video tour of the inside of their item before a buyer purchased it, but a lot of hassle to go through for a $40 or $60 item, I know. But these vintage items, they run into the repair issue of the point where you just can't get some of the parts for them anymore, or substituting parts would be a lot of work, and it's just buyer beware for the most part. And I got fairly lucky getting this one at a discount, but like I said, the panel I refinished because it had corrosion on it. You buy these unless it was reworked by somebody fairly qualified and competent, you're not going to get the results. Your values on your resistors are going to drift. Most of the capacitors are going to be junk and need to be replaced. So it's all things that need to be kept in mind if you're purchasing one of these units. So again, I thank you for viewing my channel and the content, and I hope you enjoyed or gained some knowledge from this particular work on this item. And if you are liking what you see, please feel free to give this video a like, and if you would like to see more content like this, please subscribe, and I'll try to get something out in the not too distant future for other items. And thank you again. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.